There's this great story about the mathematician Carl Friedrich Gauss where when he was a child, when he was a student in his math class, his teacher got tired of all of the children doing whatever they were doing, wanted to take a little break, and said, you know what, I want y'all to add the first 100 positive integers. And keep in mind, this was a couple hundred years ago. This wasn't just like bust out your calculator and type 1 plus 2 plus 3 all the way up to 100. This was, you've got your own little blackboard and you were going to write out the sums all the way 1 to 100. This is like a 15-20 minute activity. So, teacher tells everybody to do this, sits down at his desk, takes a big sip of coffee. Gauss throws up his hand. Teacher, I've got the answer. I don't want to actually spit coffee out because it'll get my stuff messy. If you add all of these together, you're going to get 5,050. Teacher says, what? Teacher doesn't even know the right answer. Teacher was just going to have a bunch of students answer, and if they got the same thing, presume that was the correct answer. So he says, Gauss, how did you add those so quickly? So Gauss shows him. Gauss takes the same exact list, all the integers 1 through 100, but Gauss writes it backwards. 100 plus 99 plus 98, all the way down to plus 1. And when you line it up this way, if you add vertically rather than horizontally, you'll notice something interesting. 1 plus 100 makes 101. 2 plus 99 makes 101. 3 plus 98 makes 101. All the way down the list until you get to those last two numbers, 100 plus 1, which of course also make 101. So now we have the potential for a shortcut. We know that we're just repeatedly adding a bunch of 101s. How many 101s? Well, our original list had 100 numbers in it, so there must be 100 different vertical sums. So Gauss has taken a really complicated problem, adding 1 plus 2 plus 3 all the way up to 100, and turned it into a very simple product. 100 times 101 is 10,100. Now, remember, that was not the actual sum. The sum was 5,050 because Gauss had to bring in a whole second copy of this sequence in order to make this work. And so now we're going to have to take this result, 10,100, and divide it by 2. And so the result of that division, 5,050, is our actual sum for the integers from 1 to 100, courtesy of Gauss, who probably was tired of his teacher yapping.